In earlier section, we have learnt union, intersection, and difference of two sets. In this section, in this exercise, we will go through some practical problems related to our daily life. We use that previous knowledge which are applied in our daily life. Okay, my dear children. Now, these are the points or concepts we learn in the exercise 1.6. See the first point. Let A and B be finite sets and A intersection B is equal to 5. If A intersection B is equal to 5, what are the two sets called? Disjoint sets. There are no elements in common, so they are said to be disjoint sets. In that case, n of A union B is equal to n of A plus n of B. I have shown the given data in the Venn diagram. See here, this is Venn diagram. A and B are disjoint sets. There are no elements in common. In that case, if you want to find n of A union B, we have to add n of A plus n of B. Understood this point, my dear children? Right. Now come to the next point. In general, if A and B are finite sets, then n of A union B is equal to n of A plus n of B minus n of A intersection B. Remember this formula, my dear children. This is very important for the exercise 1.6. Okay, my dear children. See here, I have shown the given data in the Venn diagram as in this figure. Universal set A and B are two subsets of universal set. See here, this part, only this part denotes A minus B, means A only but not B. And this part denotes B minus A, means B only but not A. And this part, common part denotes A intersection B, means A and B. Okay, my children. So, if you want to find A union B, we can add this part A minus B, A intersection B, B minus A. If you observe, these three parts are disjoint sets. If two sets are disjoint sets, in that case, how do you find union of the two sets? By adding the n of A and n of B. Similarly, this is one part and this is another part and this is another part. Three parts are there. By joining these three, we get A union B. Therefore, we can derive this formula like this. N of A union B is equal to n of A minus B, this part, plus n of A intersection B, middle part, plus n of B minus A. Understood, my children? But in general, in the exercise 1.6 problems, to solve the problems in exercise 1.6, we use this formula only. Okay, my dear children? But to understand the concept, I have written this formula. Okay, my dear children? Right. Now come to the next formula, third one. N of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. This is also important formula for exercise 1.6. Okay, my dear children. So learn this formula also well. Okay, my dear children. Now I have taken a Venn diagram. This is a universal set. In this universal set, A, B, and C are three subsets of universal set, and they are not disjoint. Means some elements are in common. In this case, I have divided the entire picture, the entire Venn diagram into 8 disjoint sets. This first part, this part only. A only. The first number, this part denotes A only. Here, this part denotes B only. Only B. And this part denotes only C. If you observe, all these 8 parts are disjoint sets. There are no elements in common. Okay, my children. Now, fourth, this part, only this part. This part denotes A and C. A and C only, but not B. Similarly, fifth part, this part only this part denotes A and B only, but not C. A and B. This is a common part, but not C. A and B only. Similarly, sixth part, only this part. This part denotes B and C only, but not A. And seventh part, this is small part, triangle shaped part, A and B and C. That is A intersection B intersection C. Okay, my children. Now eighth part, outside the part. Okay, my children, in the universal set, after deleting this entire part, this is eighth part. A union B union C whole dash. That implies that is said to be neither A nor B, neither A, neither B nor C. Okay, my children. In words, we can use these words neither A, neither B nor C to denote this area, this part of the universal set. 5 plus 7. See this part plus this part. If we add these two parts, what will you get? A intersection B. Understood, my dear children? Now, if we add 4 plus 7, this part plus this part, if we add these two parts, we get A intersection C. And if this part and this part is added, what will you get here? B intersection C. Understood these points, my dear children? Right. Now, the concepts of exercise 1.6 were over. Now we will start the sums in exercise 1.6. Page number 24. Page number 24. First question. Question number 1. If x and y are two sets such that n of x is equal to 17, n of y is equal to 23, and n of x union y is equal to 38. Find n of x intersection y. N of x intersection y. Now we know that n of x union y, n of x union y is equal to n of x plus n of y minus n of x intersection y. Okay, my dear children. So in this formula, we substitute the given values. What is n of x union y? 38 is equal to, what is n of x? 17 plus, what is n of y? 23 minus n of x intersection y. We don't know its value. We have to find its value. Okay, my dear children? Right. This implies 38 is equal to 17 plus 13. What will you get here? 40 minus n of x intersection y. Now we have to solve this for equation to find the value of n of x intersection y. This implies n of x intersection y is equal to 40 minus 38. We are sending this 38 to RHS. Then it becomes minus 38. Understood this step, my dear children? Right. This implies n of x intersection y is equal to 40 minus 38. What will you get? 2. Understood this my dear children? Right. Now come to the question number 2. Question number 2. If x and y are two sets such that x union y has 18 elements, x has 8 elements, and y has 15 elements, how many elements does x intersection y have? Understood this question, my dear children? This question is the same as that of the first question, but presentation is different. So here X union Y has 18 elements. We denote it symbolically. N of X union Y is equal to 18. Understood this, my dear children? Right. X has 8 elements. We can write this sentence like this: N of X is equal to 8. Similarly, Y has 15 elements. We can write this sentence as N of Y is equal to 15. We wrote the given sentences by using the notations. Understood this, my dear children? Right. Now we know that n of x union y is equal to n of x plus n of y minus n of x intersection y. You know this formula. In this formula, let us substitute these values. What is x? N of x union y? 18 is equal to n of x. What is n of x here? 8 plus what is n of y? 15 minus n of x intersection y. We don't know its value. Understood this step, my dear children? Right. This implies 18 is equal to 8 plus 15. What will you get? 23 minus n of x intersection y. Now we are bringing this minus n of x intersection y to LHS, and we are sending 18 to RHS. Then we get n of x intersection y is equal to 23. It becomes minus 18. 23 minus 18, what will you get? 5. So this is the value of n of x intersection y. Is it clear, my dear children? Right. Now come to the question number 3. Question number 3. In a group of 400 people, 250 can speak Hindi and 200 can speak English. How many people can speak both Hindi and English? Okay, my children. This third question is also same that of first two questions. Okay, my children. Let us consider H denotes the people who can speak Hindi and E denotes the people who can speak English. So I wrote a sentence. Let H and E denote the people who can speak Hindi and English respectively. Okay, my children. Then I am writing the given data by using the notations like this. N of H stands for number of people who can speak Hindi. How many people can speak Hindi? 250. So N of H is equal to 250. Understood this part, my dear children? Right. Next, N of E. N of E denotes the number of people who can speak English. How many people can speak English? 200. So N of E is equal to 200. Understood this step, my dear children? Right. Next, N of H union E. How many people are there in the group? 400. So N of H union E is equal to 400. Understood this step, my dear children? Right. Now we have to find N of H intersection E. It means the number of people who can speak Hindi and English. That is question mark. Understood this step, my dear children? Right. We know that N of H union E is equal to N of H plus N of E minus N of H intersection E. This is the formula I told you in the beginning of the exercise. In this formula, we substitute the given values. N of H union E. What is N of H union E? Here 400 is equal to N of H. What is N of H here? 250 plus N of E. What is N of E here? 200 minus N of H intersection E. We don't know the value of this N of H intersection E. We have to solve this equation. Understood this step, my dear children? Right. This implies 400 is equal to 250 plus 200. What will you get here? 450 minus n of h intersection E. Understood this step, my dear children? Right. This implies n of h intersection E is equal to 450 minus 400. I have brought this term to LHS. It becomes n of h intersection E. And I am sending 400 to RHS. It becomes minus 400. That is why we got this step. Understood this step, my dear children? Right. This implies n of h intersection E is equal to, what will you get here? 450 minus 400? 50. So, how many people can speak Hindi and English? 50. So, finally, I wrote the sentence form. Therefore, 50 people can speak Hindi and English. They can speak the both languages, Hindi and English. I represented the given data by the means of Venn diagram here. See here in the universal set 400. This is the circle. This circle denotes who can speak Hindi, and this second circle denotes the people who can speak English. So n of h is equal to 50, n of e is equal to 200. Sometimes we use the Venn diagrams to solve the problems easily without without using the formula. Okay, my dear children? Right. Now I'm explaining the question number 6. I'm not explaining the question number 5 and question number 4. You try the question number 4 and question number 5. They are also same that of the first 3 questions. That is why I'm not explaining question number 4 and question number 5. So, question number 6. Come to the question number 6. In a group of 70 people, 37 like coffee, 52 people like tea, and each person likes at least one of the two drinks. How many people like both coffee and tea? This question is also same that of the previous questions. The presentation of the question is different but same question. So let us consider C and T denote the people who like coffee and tea respectively. Okay, my children, we are assuming that letter C and letter T denote the people who like coffee and tea respectively. Now we are representing the given data in the form of notations. N of C union T means how many people are there in the group? 70. So N of C union T is equal to 70. How many people like coffee? 37. So N of C is equal to 37 means number of people who like coffee, that is equal to 37. Now how many people like 50 tea? 52 people like tea. So n of t denotes number of people who like tea. How many people? 52 people like tea. So I wrote this sentence. Understood this step, my dear children? Right. Now we have to find n of c intersection t means how many people like both coffee and tea. We have to find its value. Understood this step, my dear children? Right. We know that n of c union t is equal to n of c plus n of t minus n of c intersection t. With the help of this formula, we find n of c intersection t. So in this formula, we substitute the values. What is n of c intersection c union t? 70 is equal to, what is n of c here? 37 plus what is n of t here? 52 minus n of c intersection t. We don't know its value. Now we have to solve this equation for finding the value of n of c intersection t. Okay, my dear children? Right. This implies 70 is equal to 37 plus 52. What will you get here? 89 minus n of c intersection t. Understood this step, my dear children? Right. This implies we are finding n of c intersection t. So n of c intersection t is equal to 89 minus 70. Understood this step, my dear children? Right. This implies n of c intersection t is equal to 89 minus 70. What will you get here? 19. So 19 people like both coffee and tea. Understood, my dear children? Right. Now come to the question number 7. Question number 7. In a group of 65, in a group of 65, 65 people are there. 40 people like cricket. 40 people like cricket. 10 people like both cricket and tennis. Okay, my children. How many like tennis only and not cricket? We have to find how many people like tennis only but not cricket. This is the first part of the question. How many like tennis? This is the second part of the question. Okay, my dear children. Now, let us consider the letter C denotes the people who like cricket and the letter T denotes the people who like tennis. So I wrote this sentence. Let C and T denote the people who like cricket and tennis respectively. Okay, my children. Then the given data can be represented with the help of notations like this. N of C union T. How many people are there in that group? 65. So N of C union T is equal to 65. N of C means how many people like cricket? 40 people like cricket. So N of C is equal to 40. And N of C intersection T. How many people like cricket and tennis? 10. 10 people like both cricket and tennis. Okay, my dear children. Understood these steps, my dear children? Right. So here, how many people like tennis only but not cricket? We represent this one like this. N of T minus C. T only, tennis only but not cricket. How many people are there? And next part, how many people like tennis? They asked like this. Okay, my children. Now we use this formula. We know that N of C union T is equal to N of C plus N of T minus N of C intersection T. With the help of this formula, we find first N of T. Okay, my children. I represented the given data by the means of Venn diagram. See, in this diagram, U, universal set, 65 people are there. This circle denotes number of people who like cricket and this circle denotes the number of people who like tennis. See here, first I wrote here 10, means 10 people like both cricket and tennis. Then in that entire circle, how many people should be there? 40. Already 10 people are there. The remaining 30 people I wrote here. So these 30 people like only cricket but not tennis. Similarly, here we have to find how many people like tennis only but not cricket. Okay, my dear children, understood the Venn diagram? Right. So, in this formula, I am substituting the values. N of C union T. What is N of C union T? 65. 65 is equal to, what is N of C? 40. 40 plus N of T. We don't know. So, plus N of T. Minus N of C intersection T. What is N of C intersection T? 10. So, I substituted the values in this formula. Understood this step, my dear children? Right. This implies 65 is equal to 40 minus 10. What will you get here? 30 plus N of T. Now we solve this equation to find the value of N of T. So this implies N of T is equal to, I am sending this 30 to this side. Then it becomes minus 30. So 65 minus 30. What will you get to 60 minus 35? 65 minus 30? That 35. We get here 35. Therefore, What does this notation denote? Number of people who like tea. Therefore, I wrote here 35 people like tennis. Okay, my dear children? Right. Now, the second part. Second part. N of t minus c means who like tennis only but not cricket. So, how do you get this part? From this entire t, from this entire circle, if you delete this part, we get n of t minus c. Observe this Venn diagram, my dear children. So, n of t minus c can be found by n of t minus n of t intersection c. By using this formula, we can find n of t minus c. Understood this part, my dear children? Right. That is equal to n of t. We found here n of t is equal to 35. So 35 minus n of t intersection c already given in the question 10. So 35 minus 10. What will you get here? 25. So these 25 people, like only tennis. These 25 people like only tennis, but not cricket. Therefore, 25 like only tennis, but not cricket. Understood, my dear children? Right.